some things we're going to look at in lesson 3 are, one, the Pythagorean theorem. Yes, you already know the Pythagorean theorem to some degree, but what happens if we get into triangle inequalities, which we can talk about the Pythagorean theorem as far as inequalities. What's an inequality? Not equal. So you're talking about greater than or less than. So what happened? What is Pythagorean theorem? A squared plus b squared equals c squared. So what happens if a squared plus b squared is greater than c squared? Or what happens if a squared plus b squared is less than c squared? What's scaling mean? None of the sides are equal. Pythagorean theorem is used for what? Right triangles, which is classification based off of its sides. So if you have a squared plus b squared is greater than c squared, that's going to lead us into determining if we have an acute or an obtuse triangle, something that is not right. So we're going to look at that, triangle inequalities. We're going to talk about similar polygons, which you've already done some in Algebra 2, and then similar triangles, which you've also done in Algebra 2. But we're going to look at it maybe in just a little bit different manner than you've used, because before, if they're similar, you've just done a scale factor in order to find a certain side length. So the first thing, Pythagorean theorem. You were already able to tell me that Pythagorean theorem is a squared plus b squared is equal to c squared. And when you talk about that, you have a right triangle. A and B are referred to as what sides of your triangle? The legs. So we know that this is a leg and this is a leg. And the third side opposite of that right angle is the hypotenuse. So A and B are both legs. Doesn't matter which one. A does not have to be the base and B the height. It's whichever way you write it down. And C is always the hypotenuse or the longest side. All right, we were good with Pythagorean theorem. But what happens is the sum of the lengths of any two sides of any triangle is greater than the lengths of the third side. What happens? Okay, the first thing we need to look at is the sum of the lengths of any two sides of a triangle is greater than the length of the third side. What happens if they are not? So if I were to talk about these two purple sides here, and they didn't want to snap together. Okay, would you, oh, that one actually worked. I have to find something different here. They're the exact same. Okay, here's what I want to point out. The sum of these two orange line segments is not greater than the blue. And it says that the sum of two sides has to be greater than the third side. Why? Because if it is not, and I move these together in order to get a triangle, are they ever going to come together to hit the triangle? No. So the sum of any two sides, you usually say the sum of the shorter two sides has to be greater than that third side so that a triangle can be created. Aaron, I don't know, but if somebody messes with my hair, that puts me to sleep. So I'd hate to have Aaliyah go to sleep because you're messing with her hair. I don't know, I'm just saying. That really relaxes me. So the sum of the lengths of any two sides of any triangle has to be greater than that third side, or else you don't have a triangle that is created. Pythagorean inequalities.
Wait, can they ever be to a certain length where they're too long?
What if they are too long? No, you're still going to get it. Okay, here's a triangle right here, right? So if I look at that triangle, is the sum of the blue and the green larger than the orange? Yeah. And does it form a triangle? Yes. Is the sum of the blue and the orange greater than the green? Yeah. Forms a triangle. The only two, obviously, if you have the longest side, I would hope it would maybe be larger than the smallest side if you add the next side to it. I don't care what two sides you pick. I don't know what I did the first time. Orange and the green is greater than the blue. We could say the blue and the green is greater than the orange. They just have, the two have to be greater than the third. Pythagorean inequalities says this, and the best way, I don't memorize the formula to decide what it's going to be. I visualize what it's going to be. That's the way I have to do it. So the question is, inequality, what happens if a squared plus b squared equals c squared? That's a right triangle. Okay, we've had that drilled into our head. We've done that a lot. But now what happens if a squared plus b squared is greater than c squared? Or what happens if a squared plus b squared is less than c squared? Now, if you remember when we were talking about a right triangle or where Pythagorean theorem comes from, what it says is if you were to make a square off of this side, that's where a squared comes from, and make a square off of this side, b squared, the sum of those areas should be the same as the area of the square that you form off of this side. If a squared what happens if the hypotenuse is shorter? What happens if that hypotenuse is shorter than being equal to c squared? So would you agree that if I had this blue length here, it would not create, even better yet, let me put the green there. If I were to put the green there as the hypotenuse, actually not even a hypotenuse. Okay, so if my hypotenuse is shorter than the two sides, in order to get a triangle, this has to come in, and now what type of a triangle do you have? Obtuse or acute? Acute. You have an acute triangle when c squared is what compared to a squared plus b squared? Smaller. So if the hypotenuse is smaller, then you have to fold the leg in, and it becomes an acute triangle. Thank you. What happens if the hypotenuse is longer? I have a right triangle right now, right? Right here, a squared plus b squared equals c squared. What happens if c squared is bigger? If it's bigger, you have to take your right angle and move it out in order to get a triangle, right? That gives you what type of a triangle? Obtuse. So this is an obtuse triangle. They're going to give you 3 angle measures, or 3 side measures. They're going to give you 3 side measures, and they're going to ask you, is that a right, acute, or an obtuse triangle? Now, when you do it, I would do as if you were working with Pythagorean theorem, because they're not going to draw the figure for you. You all right? I would put it in order from smallest to largest in side length. So your smallest squared plus the medium distance squared is equal to the longest one squared. And then compare them and see what the comparison ends up as. Let's see what I got here. The lengths of the sides of the triangle are 7, 5, and 4 respectively. Is the triangle a right triangle, an acute triangle, or an obtuse triangle? So like I said, I would just go in order. If it were a right triangle, then the 2 legs, which have to be the shorter side, would be equal to the hypotenuse squared, which is the longest side. A squared plus b squared equals c squared. What's 4 squared? 16 plus 5 squared? 25, which gives you a value of 41. 7 squared is 49. I don't memorize a squared plus b squared is less than c squared. My whole thought comes is I just create a visual picture and I say, if that was an equal to statement, it would be a right triangle. The hypotenuse is longer, so what do you have to do with the leg? Drop it out, which makes it outside of the triangle. Up to.
You just like make that side length whatever you want to make like the orders. Like you could have like 7 and 5, you know, just the word on it. 7 or 1 is like
If it happened to be okay, so then if I told you this, if I had side lengths of 4, 5, and 3, if I had side lengths of 4, 5, and 3, and if I were to do that and say 4 squared plus 5 squared and 3 squared, 16 plus 25, 41 compared to 9. You can't do that because what do you know about a 3, 4, 5 triangle? It's a right triangle. We have a special right triangle known as a 3, 4, 5 triangle. That's a special type of right triangle because 3 squared plus 4 squared, you get 9 plus 16, which is 25, which is the same thing as 5 squared. So I always go the smallest to the largest. Because I always say a squared plus b squared equals c squared. For those of you that might be left-handed or left brain, right brain, whatever, and go c squared equals a squared plus b squared. I suppose that. But visually, mentally, what I have to do is I have to decide, is that hypotenuse greater than or less than, what's the yellow going to create? Yep. I just sit there and I say, okay, the blue would create a right triangle, right? And if the hypotenuse is shorter, it becomes acute. If the hypotenuse is longer, it becomes obtuse. Those two things. Visualize it. That's what I have to do that. I still sit there and I say, okay, the hypotenuse is longer, so you got to drop this side out. Makes it obtuse. Let me stop this for a second and ask you to look at one in your book. Special types of quadrilaterals are parallelogram. When you have two pairs of parallel sides. If you have one pair of parallel sides, what do you call it? No, a rhombus has 4 sides. A rhombus is a special type of parallelogram. It's a special type where all 4 sides are equal, so it's an equilateral parallelogram. If it's an equiangular parallelogram, then it becomes a rectangle. A square is a special type of rectangle and rhombus. It's a special rhombus because it's equilateral, but it's special because all 4 angles are equal. It is a rectangle because all 4 angles are equal, but it's a special type because the sides are equal. So that's a square. A square is a special type of rhombus and rectangle. A square is a rhombus and a rectangle. So they are both, all of those are parallelograms. Parallelograms are rectangles, rhombuses, and squares. A rectangle definition is that it's an equiangular parallelogram. If it is not a parallelogram, you could have one pair of parallel sides. Do you know what you call that? What's one pair of parallel sides? Looks like this. Trapezoid. And if it has no parallel sides, what do we call it? No parallel sides. No. What would it look like? Try this. There's 1, there's 2, there's 3, and there's 4. Are any of those parallel? No, you have no parallel sides. That's referred to, it's not a kite unless these two sides would be equal in length and those two sides would be equal in length, and they're not. So that, and you could, a kite is a special type. I mean, that can be one, because you don't have any parallel sides. But in a kite, you have two pairs of congruent sides, and that you don't. Collectively, they are all called a trapezium. Not to be confused with a different culture. I'm not quite for sure which culture switches definition of trapezium and trapezoid around. But it does. No, if I would go to Wolf brand, I would be able to find it, but I don't know what it is. We talked about the naming of them. What do you know about the number of vertices versus the number of sides in a polygon? They're equal. They're the same. And do you know the difference between concave and convex? Concave, KJ, convex, does not. Equilateral means what? All sides are equal. Equiangular means equal angles.